Okay, let's officially start the contents of the course. And what I want to do to begin with, I just want to walk you through some things from your WHIT and WHIT book. So if you have this with you, you might want to thumb through your hymnal with me. Otherwise, you can follow along in the recording later, or you're not gonna. I'm not gonna. There's not gonna be anything there I'm not gonna talk about, but it'll help you if you look at it yourself. So let's see if I can do this. You'll have to be patient one of the clunky things about this kind of technology is that it's difficult to shift from showing you at home one thing to another. Okay. All right. Pardon my computer, it can't spell well. Essentially, there are two types of statistics. Descriptive statistics, and I've already used that word when I was talking about the content a minute ago. Descriptive statistics and inferential statistics. Well, when's the last time you used statistics? Anybody? You used statistics lately? Some presentation, like how'd you use it? Okay, a percent of students reading grade. Okay, 14%. That is a statistic. It describes something. That's an example of descriptive statistics. Okay, let me refine my question a little bit. When's the last time you used statistics in quote unquote real life? And weigh in at home too, please. Real life. Or when's the next time you plan on using statistics in real life? If you're missing this at home, I've got this deer in the headlight looks here. Okay, so you communicate with parents something about your student's performance. Give me a non-educational example. I mean, those both. Okay, 9 out of 10 dentists recommend Colgate. Yeah, that's a statistic. Now, that example puzzles me a little bit, though, because and this is one of my pet peeves, and I, that's a little out of order, but I'm going to, since you brought it up. The commercial actually went like this. It was a Trident commercial. Trident sugarless gum. The commercial went like this. I think I have my numbers right. Doesn't matter if I do or not. But 3 out of 4 dentists recommend sugarless gum for their patients who chew gum. I have no qualms with that, but I've got a lot of questions about it. So what they want you to hear, oh, Trident is good for you. No, it's just not as bad for you as sugar gum is. Now, what I want to know is who's that fourth dentist who says, yeah, go ahead and chew the sugar stuff. Watch, as we go through this class, here's what I was going to say. As we go through this class, pay especially close attention to commercials. Commercials are wonderful examples of statistical misuse. I'm not saying most of them lie. Most of them tell you the truth. But they try to infer, here as in inferential, they try to infer something that's not necessarily true. It'd be better if you didn't chew gum at all, but if you're going to chew gum, no sugar is better than sugar. I mean, that's probably their idea. But you're hearing, oh, Trident's good for you. No, it's not. But watch commercials. We'll give some examples as the course goes on. But descriptive and inferential, okay, good examples both. But so you've got an example of statistics that X number of dentists or X% of dentists recommend something. But okay, what about the other part of my question? When's the next time you plan on using any kind of statistics? I can answer even if you can't. If you're here, sorry folks, those of you playing the home version of the game, if you're here, I imagine you're going to drive home after a while. How do you know if you're going too fast or too slow? You rely on the speedometer. That tells you a rate. That's a statistic. Anytime you count or measure things, you're using statistics, at least some level, counting or measuring. And there's a lot of statistics that are beyond that, but that's a good start. My point is just to show you that you do this stuff all the time, whether you think about it or not. And math teachers are notorious for making things more difficult than they have to be, because it turns out you know a whole lot more about stuff than they let you let on. Otherwise, we might be out of a job if we knew you knew this stuff already. So, but hopefully you'll learn some things about statistics here that you may know a lot of, but you hadn't thought about it that way. So my job is to get you. Part of my job is to get you to think about things in a certain way, to recognize certain things. Yeah, I can't wait till I'm on my way home where I can use descriptive statistics to see, or decide how much gas I need or whatever, how far it is. Those are all statistical applications, but you don't think of it that way. So you do this a lot. And when I ask you the first question, do we lose volume again? Or are we okay? Can you still hear me? I can check. Okay, thank you. Okay, I have to keep checking. And sometimes my microphone just goes off, so you'll have to tell me when that happens too. Which if that happens, I can fix that. You know what it is. Anyway, two kinds of statistics. Descriptive, which most of the examples we just gave are. Descriptive is this is sort of a well-done thing. Guess what descriptive statistics do? They describe things. Typically, descriptive statistics tell you about the things you're talking about. Inferential statistics tend to help you make generalizations beyond your sources of data. For example, in education, if you know a particular teaching method is associated with higher test scores, that might imply that that particular teaching method should be used beyond just the people you collected the data from. So descriptive statistics describe, inferential statistics infer. Mention a couple of words. I mentioned your sources of data a second ago. So let me just kind of expose you to a couple of other terms. Just again, we'll sort of have these random vocabulary lessons because we're going to use these terms later. It kind of be nice if you knew what they meant. We talk about population and samples. And population is all the people you want to talk about. I'll give you an example in a minute. And sample consists of the people from whom you're collecting data. For example, let's say you wanted to know something about all third graders. I don't know, how many third graders are there in the country? The technical answer is a bunch. You're probably not going to be able to collect data from all third graders. You're going to collect data from some third graders. So in this case, all third graders would be the population. And the sample would be those third graders from whom you collect data. Because in general, it's not practical or even possible to collect data from the population. Now, if your population is third graders in Sullivan County, then you may be able to collect data from all those people. So you wouldn't have a sample, you would just have a population. So when your research tends to be pretty narrowly focused in terms of people or subjects, then sample may or may not apply. Questions, thoughts, comments about broad kinds of statistics and the difference in population sample. This is going to be one of the shorter videos, I think, but we're going to use these terms a lot. I'm not going to ask you on a test, you know, to give me. I might ask you to give me an example of the descriptive statistic, but I'm not going to ask you to define it. I mean, I want you to know what it is, be able to use it and identify it. But I mainly give these vocabulary lessons so you know what I'm talking about when we use the terms.